Hello everyone, welcome to our CSC 461 final project submission. We are group number 14. I am Sadman Joshim Sakib. I am going to explain how we implemented the robot along with the IR sensors and also the 3D track. My teammate Zahin Raida will describe the implementation of the PID control code.
This is our line following robot. We brought some changes in our previous robot. We added three sensors. This is the left IR sensor, this is the mid IR sensor, and this is the right IR sensor. We named these three sensors according to our code. And also, we set the type as infrared. Here we can see, if we go inside the sensor, we can see we set the type as infrared to detect whether the robot is on the track or not. We set this in all the three sensors. We can see all the three sensors are pointing downwards.
Now we go to the Tinkercad website to draw the 3D model of the track. We export the object file. We import the 3D model from the location where we exported the object file. We scale the 3D model accordingly and rotate it to make it parallel with the floor. We place the robot on the track. Thank you.
Hello everyone, thank you Sadman. Now I'm going to explain our PID control path following code. For that, we set the controller as path follower. In the path follower code, we can see that we import the robot class from controller module and create a instance of robot in robot. We set the time step value as 64 and set the initial value of the speed as 5. We set wheel's rotational motor name as wheel 1, 2, 3 and 4. We set the position of the wheels as infinity and set the velocity 0. For the IR sensor, we set the right IR name as right S, mid IR as mid S and left IR as left S. We enable the IR sensor using time step. For the PID part, we take some important variable and some constant. For the proportional controller KP, we take the value 0.03. Integral controller value Ki, we set the value as 0.001 and in differential controller KD value as 0.5. We set these three controller values using trial and error method. Then we write our PID method giving the parameter error and returning balance. We set the speed and we set speed using our set speed method and giving the parameter speed and the balance that we are getting from the PID method. Then we taking a threshold value of our sensor as 900 and distance value as 1000. Our threshold value is defined if our robot is on the white surface or on the track, and distance will measure the distance from what distance our robot is. Then we will see the IR sensor conditions. In the first condition, we can see that our left IR value and the right IR value is less than IR threshold value and mid IR value is greater than IR threshold value. That means our robot is on the right track and error will be 0. Then we called our PID method for balance and set our speed. This balance and set speed method will be same for all rest of the conditions. If our left IR value is less than IR threshold value and right IR value is greater than equal right IR threshold value and mid IR value is greater than equal IR threshold value, then our robot has to move to the right and distance error will be distance. If our left IR value is greater than equal IR threshold value and right IR value is less than IR threshold value and mid IR value is greater than threshold value, that means our left IR sensor is on the track and right IR sensor and mid IR sensor on the white surface. That's why our robot has to go to left and error will be minus distance. If our left IR value is greater than equal right IR threshold value and right IR value is less than IR threshold value and mid IR value is less than IR threshold value, then the robot has to go to the left and error will be minus distance. If our left IR value is less than IR threshold value and right IR value is greater than equal IR threshold value and mid IR value is less than IR threshold value, that means our right IR sensor is on the road and left IR sensor and the mid IR sensor on the white surface. Then our robot has to move to the right, and for that we set the error as distance. If our IR value is less than IR threshold value and right IR value is less than IR threshold value and mid IR value is less than IR threshold value, then our error will be 0 because all the three sensors outside of the track, and we set the speed as minus speed because we want our robot to back to the track. Thank you everyone. Now we will see our simulation of our robot, and thank you for hearing till now.